I build mechanical projects from time to time, and the thing that makes a project mechanical is that it has motion in it. To add motion, you can use bushings, you can have surfaces that slide against each other, but really, my favorite solution for adding motion is to have ball bearings. They last forever, they're easy to work with, they're great. That's why you see them all over the place. But the problem with bearings is if you go to the hardware store, they're going to charge you a lot of money just for one even. So we need an affordable bearing which is pretty good quality. And the solution that I found for that was skateboard bearings. And I should preface this by saying my entire experience with skateboarding comes from Tony Hawk's Pro Skater 2 on Dreamcast. So I've never actually used a skateboard bearing for skateboarding, but I've used it for a lot of other things. And I think you will find it helpful to see some of the tips that I came up with for using it. The bearing has three basic dimensions. The inner diameter is 8 millimeters, the outer diameter is 22 millimeters, and the thickness is 7 millimeters. Now that may not sound particularly helpful to someone in the United States, but they have corollaries which are very helpful. This right here is a standard 5/16 bolt. In fact, I use these so often with skateboard bearings that I have a container dedicated virtually entirely to the hardware for them. We've got long bolts, short bolts, washers, nuts, nylon nuts, etc. Anyway, the diameter, now I lost my bolt, here it is. The bolt that works best is a 5/16 bolt. This is just a standard one from Home Depot or any hardware store, very affordable. And it fits through the center with just a little bit of extra play, okay? Now that's very handy because there's really two ways to use a bearing. You can have the inner race fixed and the outer one rotating for motion, like a wheel, something like that. Or you can have the outer one fixed where it's mounted into a housing and there's a shaft or an axle that's spinning in the center. Okay, so if we want to do the wheel, we can run that bolt through there and then you run a washer onto the end of it. The bolt setup going down the center and then compressing on it pretty much solves the wheel situation. But if you want to hold it in a housing, you need something which matches the outer diameter. And as it turns out, a 7/8 Forstner bit is just a little bit bigger than the outer diameter. If you do need it to fit very snugly in there, what I often do is get some of the HVAC tape, not duct tape, but real tape for ducts. It has aluminum on the outside. I usually take that because it sticks well to metal, and I put one pass around the outside, or one turn, and then that'll fit in very snugly. So if you need an axle, you can use a long bolt like this, and then you can use two nuts to jam in order to set up the position where things are. There are a lot of options here, and I've used these things in more projects than I can count. I mean, I've got my expanding table, my counterweight desk, I've got the self-rocking cradle that had it in there. There's a cutting circle, which I'll cut in here. There's the steady rest that I built for my lathe behind me. There are tons and tons of uses for these things. You can get them for about $1 each shipped on Amazon in small quantities and other places. If you buy them in bulk, you can get them for even less than that. I don't have any particular brand to recommend. I've bought several different brands and they all worked pretty well. Some of them, like this one, is sealed on one side completely and not 100% on the other. That may or may not be a disadvantage. Something to keep in mind when you're using it in the housing setup, where the outside race is fixed and the inner one wants to rotate freely, is that these races, this is a cross-section view as stated, are at the same height. So what that means is that when you start off with your flat piece and then you drill it out with your Forstner to get a rectangular hole for the bearing to sit in, then you drill it out for your clearance for the shaft down the center. Everything looks good, you drop your bearing in there, but that outer race is here and the inner one is here. It's going to rub on there. So you want to add one extra step with a large countersink bit or just a regular one where you drill this off. And that's going to free up that inner race so it can float and rotate freely. It's not generally a huge issue. I've had projects where I didn't do it and they worked fine, but it's not visible from the outside. So if you do have something where it's under a lot of stress, you may not find out until it starts smoking or causes some sort of other issue. This is a great example of a jig made with these skateboard bearings. I needed to make this ring for the self-rocking cradle project. I made the outside on the table saw where you hold it in the center and you rotate it around the blade, but when you want to cut out the inside, that gets a little bit trickier. So what we did was we mounted 2 bearings onto here, and then the third we positioned, you just held the bearing and drilled through. And now what I have is this situation where it's trapped on the outside. And then I could take the router and move the router out to route this inside thing. It's great. It moves freely. I can apply a decent amount of force to the side or down to keep it fixed. The way that these are mounted on here is pretty simple. We've got it spaced up just a little bit. It's a bolt through the bottom. You take your bolt, you put it straight through the bearing. Okay, now that bottom, both races would be pressed against there if we did it like this. So we put 1 washer, which is small enough that it doesn't go to the outer race, and then it'll drop through there. When you bolt it down, you can bolt it down firmly, and you're off to the races. Little things like this, very handy. Now we're going to mount this bearing in the housing setup. We have a piece of 3/4 scrap Baltic birch here. We're going to take our 7/8 Forstner, go in a little more than halfway, maybe 2/3. That'll create our main depression. We'll run our regular 3/8 inch bit down through the center to clear for the shafting. And then we're going to take a 1/2 inch, just a standard countersink bit, relieve that inner race a little bit, and there you go. It's mounted. If you want to shim it out a little bit for that snug fit that we talked about, we can take some of our ducting tape here, run that one timer on the outside, and that usually takes care of it. That's it. I hope it was helpful. It's a pretty simple thing, but I'll tell you what, every time I need to add motion to a project, I turn to these skateboard bearings. As a little teaser for the future, I've started using snowmobile bearings for situations where I need larger ones. And I don't have a lot of experience with these yet. I need a little more time in the R&D phase, but I used 2 of them just the other day to repair a mower deck for Grandma's riding lawnmower. So always handy to have them. Same thing, affordable, widely available, good quality. So that's it. Lots of projects underway. Thank you for watching.